Welcome to Performance Instrumentation and Monitoring for .NET Applications. My name is Brian Beach, and I'm a Principal Developer Advocate with the Windows EC2 team at AWS. There's a couple things that I want to talk about today. I'm going to start with a quick overview of instrumentation and observability, and then I'm going to move into some of the what's new. What are the announcements that we've had in the observability space over the last year? And then I'm going to spend most of our time in a demo, and I want to spend time digging into a real .NET application and adding instrumentation and looking at the effect of that in the CloudWatch console and looking at how I'm instrumenting a .NET application. So the goal here of instrumentation is observability. Microservices have added a lot of big gains, performance gains, agility gains. We're able to bring things to market faster and more often. But that can have a kind of counter effect in observability. So as we're starting to grow, to have hundreds of microservices in production, and those microservices are being updated many times per day, it becomes really difficult to understand what caused an error. When something goes wrong in production and you're trying to fix an issue, it's super difficult to understand which one of the many changes across many services is causing that. And so there's usually three different sources that we're looking for. We want to look at the logs that are coming out of the application. We also want to look at the metrics that are coming from our resources, so out of our servers and our containers and serverless functions. And we also want to look at the traces that are the individual user flows through our application. So as a request comes into each service and how that request moves from service to service. So in the AWS world, we do that with three services. We start with the CloudWatch logs, which is sending the logs out of our applications to CloudWatch and storing them centrally. We look at metrics in CloudWatch to track things like CPU utilization, memory consumption, and then we look at X-Ray as our solution for instrumenting our application and adding traces and flows as the user moves through. So CloudWatch is probably something that nearly everybody is familiar with. This is our central monitoring service. This is the main operations hub where dashboards exist. And here you can pull in metrics, alarms, logs, and then X-Ray is a distinct service that works in concert with CloudWatch. And X-Ray is how we're instrumenting our application, but it's sending that data up to and into CloudWatch so we can see them side by side and we can use all of those different data sources together as one. And we'll see that today. So before we jump into a demo, I want to talk about some of the new announcements that have happened over the last few months. So anomaly detection, this was about a year ago, and this is really designed to make your life easier in setting up alarms. So as you're collecting metrics, in the past we collect hundreds of metrics across all of our microservices, but it becomes very difficult to understand where to set thresholds for alarms. Am I concerned when CPU utilization gets to 70% or 90%? That's hard to make those decisions on a metric by metric case. And so what anomaly detection does is it uses machine learning to understand trends and understand what's normal, and then can automatically set up the alarm so that anytime you breach above or below normal behavior, you can get a notification of that. So it's just there to make life much easier to be able to set those thresholds for you. The second one is contributor insights. Again, this is designed to make your life easier. If you've got a very high cardinality metric where you've got many sources, maybe this is the traffic coming into a load balancer from hundreds or thousands of IP addresses, it can be very hard to figure out which one of those is causing the change in behavior. And so contributor insights will let you very quickly find the source of what is causing this, which one of these many sources is causing this change in behavior, and let you focus in on it really quickly. Application insights, we've been able to do dashboards for many years, but application insights makes it much easier to create dashboards. And it's really focused on helping you pick the right metrics. What should I be focused on for this enterprise application? And it's aware of .NET, .NET Core, IIS, SQL Server, and will help you very quickly pull together the right metrics. So for a web server, you might be interested in network utilization and CPU utilization. For a database, maybe it's more important to be looking at memory utilization and disk I/O performance. So this will help you really focus in on that. The next thing that happened recently is a service called Service Lens. And what Service Lens does is it creates a dashboard to pull together all of the different data across multiple services and parts of the CloudWatch service. So it can take your events, your alarms, your logs, and your X-ray data and pull it all together into one. And this is where we're going to spend most of our time in the demo. We're going to be looking at the results of instrumenting a .NET application within Service Lens. So let's jump into a demo and take a look at how we instrument an application and the effect that that has on this dashboard. So I'm going to jump right in here, switch over to the demo. And you can see here, let's imagine for the moment that we are working for this company that facilitates pet adoptions. So there are many pets out there looking for a home and many people looking for a pet. And so you can see across the top, we have puppies, kittens, and bunnies available for adoption. And the goal is to help them find a home. So this application, like many, you can scroll through and search for different animals. You could also, up at the top here, go into search mode, and you could search by different types. And then there's also an e-commerce capability built in so that we can pay the adoption fees. As you might expect, this is deployed as a series of microservices. This is the CloudFormation template that deploys it, and you can see there's 153 distinct resources. So if I were supporting this and my pager went off in the middle of the night, it would be very hard if I wasn't intimately aware of this app to understand where and find and isolate a problem. So you can see as I scroll through here, there's S3 buckets, there's containers, there's load balancers, SNS and SQS queues. There's a lot of distinct resources in here. So if I were trying to dive into this in the middle of the night, it would be really hard for me to figure out what the source of this is. So I'm going to switch over into CloudWatch. And what I want to be able to do is look at, on the left side here, I've got the effect in the AWS console. And on the right, I've got my application running. And I'm going to show you them sort of side by side. So let's jump into CloudWatch. Hopefully everyone has seen the CloudWatch service and the CloudWatch console. Probably you've looked at things like logs and alarms in here. I'm going to come down here into Service Lens and look at the service map. So immediately you should see that this is doing a great visualization of my application. So all of those resources that we saw earlier are presented here in a map, so we understand how they fit together. You can see that there's an issue with S3. It's circled in red, indicating that there's a problem, and so it highlights that right away for me. But you can see how everything connects. Across the left, you see 4 different user entry points where they're coming into different containers. And then each of those containers is dependent on a bunch of services behind the scenes that you see. So you can understand how everything is interconnected. The bold lines indicate that there's more traffic flowing here. So there's a lot of visual indicators within this map. And you can see all the disparate services as I kind of navigate around. And as I said, there's an issue with S3 here. So you can see that that's visually indicated, and when I hover over it, I can see what's happening. And as I hover over some of these links, you can see latencies. So a lot of data is presented in this really simple visual. So let's I'm going to zoom in here, and I want to focus on this pay for adoption service. So this is one of the services. And if I click on that node, you can see at the bottom that it focuses in on the pay for adoption. It's an ECS container. And if I click on that, I get some information right away about it. We can dig much more deeply, but right away I see some high-level metrics like the latency, the number of requests, faults. At the moment there are no faults, so this seems to be performing really well. We're going to inject some faults later in the demo. And then over on the right, you see alerts. If there were any concerns or alerts raised about this part of the application, they would be surfaced here. And again, we'll see that later. Okay. So what I want to do next is let's jump over to the application and see how we instrumented that. This is the pet adoption solution, and there's multiple projects in here. So you see the pet site, that's the website, the ability to search, the list of animals available for adoption, and then the pay for adoption capability. That's the one we were looking at. That's the e-commerce capability. If we zoom into that, you hopefully immediately recognize this as an ASP.NET application. There's nothing special in here. And I'm going to start in the project file. If we jump in and look at the project file, you can see that I've imported a bunch of packages from NuGet, and there's 5 here that I want to focus on that are related to X-ray. So this first one, this is the AWS SDK for X-ray. This is a fairly low-level API. So with this, I could do things like make a call to put a specific trace into X-ray or query X-ray to get the results and to maybe build that service map that we saw in the console. Generally, though, this is fairly low level and not the way I want to be instrumenting my code through lots of little calls. There are many helpers that we call recorders that make this much easier. So these are those 4 items that you see below. The first one I want to talk about is this ASP.NET Core. This is an ASP.NET application. So this NuGet package is going to plug into the ASP.NET pipeline and handle some of the instrumentation for us. So those first 4 services that we saw that are being called, those are the ASP.NET projects. Each of those has this handler plugged in, this recorder plugged in, and that's what's giving us the first high-level data. The next thing you see is the AWS SDK. This is what's adding all of those behind-the-scenes AWS services, things like S3, DynamoDB, SNS, SQS. Anytime I make a call using the SDK, that gets instrumented. So that is my ASP.NET project, and then you see some of the other dependencies like this SQS queue that's being created by that second NuGet package. Okay. So you also see some other ones, like I've got heavy use of SQL Server in this project, and so I've included the handler for SQL Server. That's not an AWS service, so it's not built into the AWS SDK. We need to add that. And then the system.NET recorder is here to handle any calls I make to services that are not AWS. So anytime I use the HTTP client, which is part of system.NET, this handler will trace that so that I can see all those calls going out to other RESTful services that I might be interacting with as part of this. Okay, before we dive into the code, I just want to jump into app settings for a minute and make a quick call out to this ECS plugin. So I haven't said this before, but X-Ray doesn't need to run in AWS. You could use this anywhere. You could use this on-prem if you wanted to. What I'm doing here is I'm mentioning that, hey, this is running in AWS, and specifically it's running in ECS. So I want to capture some extra metadata automatically. And we have plugins for EC2, ECS, Elastic Beanstalk, and they'll capture things like what availability zone was I running in, what ECS container was this service being run from, and that happens automatically so that I don't have to add that metadata myself. I could add custom metadata if I wanted to, but if I add these plugins, it just makes it a lot easier to do that. Okay, so let's jump into the code now. This is an ASP.NET project. I'm going to jump into the startup class. It should be familiar to any .NET developer, but essentially this is where I'm setting up the ASP.NET pipeline. And so in order to set up tracing, all I've got to do is add this method called use X-ray. And that's going to plug X-ray into the ASP.NET pipeline. And particularly, I'm noting that this segment of this trace is called pay for adoption. And we'll see all the segments later as we dig more deeply into this. But you can see that here, right? There's the pay for adoption service that correlates directly to this ASP.NET application that's running as an ECS container. So that's how that node got created. All I have to do is add this into my pipeline, and it will take care of tracing all the requests. To talk about how that works, my ECS containers all live behind a load balancer. And so these traces are sent generally as HTTP headers. And so this header is how the trace is sent. And the value on the right there consists of 3 parts. The first part is what version of the AWS X-Ray SDK are we using? I'm using version 1. The second one is the time, the epoch time that this request was first seen by the first service that touched it. So that gets passed around. And then a unique identifier for this particular trace. And so what will happen is if a request comes into the load balancer and this header doesn't exist, the load balancer will add it. If it sees that the header already exists, it'll understand that this is another segment that's part of a larger trace, and it will just add that to the existing one. And all of that happens simply by adding this one line. I don't need to do any more than add this. And now every request that arrives at my ASP.NET application will start a trace for it if one doesn't exist. If something has already started the trace, for example, the load balancer, this will just be added to that existing trace. Okay, so that's a good first step. But there's more. Let's dig into the controllers because we want to see some of those backside services. So this is an MVC application, so there's obviously a controller. I'm looking specifically at the home controller here. And this is the AWS SDK handler. and I'm saying I want to register X-ray for all AWS services. So if I call S3, DynamoDB, any of those services that we saw in the map, I want to trace those calls. And so you can see them, for example, here's an SQS queue. Up above that, there was a Lambda. All of that is being traced here. I could have been more specific and said I only want to trace one service. I'm here saying trace all services for me. And I just do that in the constructor of this controller, and then everything that happens here will be traced. And then here you can see where I'm tracing a SQL command. I mentioned you can trace those as well. This one's a little bit different. Because this isn't natively built into the SQL client, I'm using this wrapper called the traceable SQL command. Essentially, this is just a wrapper around the standard SQL command, and that will initiate and end the trace so that we get this call to SQL added in. There are other handlers for things like Entity Framework. I'm not using those here, so you're not going to see them, but they work very much the same way. Okay, and again, I mentioned earlier you can trace calls out to other RESTful solutions. That was an example of one there. It just says remote. I'm not going to show you an example of that, but that works the same way as well. Okay, so with this, with just a few lines here, we've gotten really good information. We've been able to see our ASP.NET nodes here, and then the behind-the-scenes things that go with it. Next, I want to dig in a little more deeply into some of the individual traces that are being captured by ASP.NET. And so you can see at the top here, we're looking at the pay for adoption service. It's an ECS container. The next thing we see is a bunch of filters. And so here I've got it filtered by status. And again, this service seems to be performing well. 100% of the requests were successful. There are no errors or faults. As I scroll down, I get some information about my response times, and I get this histogram. Here it's saying about 50% of my requests finish in 1 second or less, and 99% finish in 2.4 seconds or less. So not bad, not great, but this is just a sample app. As I scroll down below that, we start to see the individual traces. These are individual traces of a particular user's flow through the application as he talks to a series of microservices. Okay. I'm going to drill into one of these in a minute, but I don't want to go there quite yet. If we scroll back up, you can see there's lots of things that I could have filtered this by, not just the status. And as we get down to the bottom, you start to see some custom ones. So I mentioned we have adoption for puppies, kittens, and bunnies. I'm going to filter this by bunny. And what's important here is I'm filtering this by something that's very business specific to our problem. So clearly this was something that I had to instrument myself in order to go in and be able to filter like this. So I want to take a look at how we do that so that we can just see the requests that are related to a particular business problem. Okay, in this case, bunnies on our adoption app. So if we jump over into the code, I'll show you how to do this. So this is called an annotation. And if you scroll here, scroll up a little bit, you can see as I'm tracing this in this complete adoption method, I'm mentioning what pet type is being adopted and then the specific pet ID. And so I'm adding those as simple key value pairs. And that allows me to filter all of my traces by that later. And I can add whatever custom metadata I want here. Doesn't matter what I'm doing. And you can see directly below that, there's this SQL string that I'll show you in a minute when we drill in. Okay, so now we're looking at a specific trace. And here at the top is a high-level map, very similar to the map that we saw earlier, but now we're just seeing this particular trace and exactly what microservices it touched. So I can watch its flow. It went from the pet site into the pet adoption method. That was talking to SQL Server, and then ultimately made this call that I'm following down into Lambda through API Gateway. So I can look at now, this is an individual user's interaction with different microservices as he flowed through. If there were a problem with this, and we'll see that later, I'd be able to very quickly isolate what happened. As we scroll down, I see the timeline. So this is my overall trace, and then you see each of the segments, the pet site at the top, the adoption next. Below that, I start to see all of the metadata related to this, all of the data. So here's my annotations. When I added that bunny to it, it gets captured there. And then below that were some logs that we'll dig into a little bit later on. Okay, so let's click on Pay for Adoption. You can see I'm in the Pay for Adoption segment. Again, this is a segment of a larger flow. And there is some really important pieces here. The adoption process is really critical to our business. The last thing I want is somebody to be in the middle of the adoption process, think that they have found their pet, and then find out that it's not available. So this is a really critical section. And so I'm labeling it as a subsection and saying this is important, really important what happens right here. And so this is the update adoption status. And this is important both to users, because I don't want them to be heartbroken that they haven't been able to adopt their pet, but it's also really critical from a technology standpoint, because there's some locking transactions in the database here. And I want to make sure that we've really instrumented this, because this is an area where I expect there to be problems. And so you can see that here. You can see that in this timeline flow, you can see not just the pay for adoption, but then those subsegments that I've manually added so that I can really be laser focused in on what's happening there. So, and then immediately after I do this second one that you can see there. Okay. So let's go back to pay for adoption, and then I want to scroll down and let's look at some of the data that we've collected. I already mentioned the bunny here, and I showed you that SQL command that I was tracing earlier. I've added this not as an annotation, but I've added the actual SQL command. That's right there. And I've traced that, I've captured it as metadata here. So rather than annotation and metadata. Annotation, again, is a key value pair that I can filter by. Metadata is just something that I want to add in. If we look at this query, you can see there's a GUID in there, there's the date that it was executed on. This would be such high cardinality and so specific that it wouldn't make sense for me to filter on this. This is just something that I want to capture so that I can see it later and it becomes part of my trace. So you can add whatever data you want here. And then I'll just call this out quickly. I mentioned that ECS plugin that's adding some metadata automatically. Because this is ECS and I've added that plugin, it is capturing what container that was running in. So this particular request that we're seeing right now is being served by this specific container. So if I had a problem, I could trace it all the way back down to the individual container that it was running in. So really powerful ability to add custom metadata here. Okay. I mentioned that Service Lens allows you to correlate lots of things together. So you can see here, this is a Docker container running in ECS, and I'm just writing out to the console. Anything that gets written to the console from a Docker container gets captured in our logs. And then you can see here that I am mentioning in the logs that I am in the complete adoption action method. And what's really cool is even though these are distinct things, right? X-ray is going off to the X-ray service, this log file is getting sent over to CloudWatch logs, all of that gets correlated together. And so now I'm seeing all of the log events that are correlated with this particular trace. And so you can see just to the right of what's highlighted now, you can see that I'm in that complete method. Okay. So just a broad overview, right? We're bringing together all of this metadata. We're correlating it with our logs. We're able to see it all in a service map. Really powerful already. I'm going to leave the pay for adoption solution here, and I want to go into the pet site project. And I want to go in here for two reasons. One, there's a good summary where we use all of these different pieces together. And then also there's a place where I'm capturing an error, and I haven't shown you that yet. So let's go take a look. We're going to be in the index method for search. So this is anytime someone clicks on the search capability. And you can see I'm starting a new segment for that, saying that I'm about to call the search API. And then I capture a bunch of metadata. What was this user searching for? What pet type, the particular pet ID if he put one in, what pet color is in his search. You can see I'm writing out a couple times to the console, again, capturing logs. And then we go into this try catch block. And what's important here is whenever there's an exception, I'm going to log that and add this exception into my trace. And then in the finally block just below it there, you'll see I will end that segment and make sure that regardless of what happens here, we make sure that we end our segment. So this, I think, is really, it's important that you capture all of your errors. I don't have one to show you yet. We will in a minute, but I'll come back to that shortly. So I've taken, just to kind of step back for a minute, we've looked at how to instrument a .NET application. We've shown how just adding a few lines of code can help build this really complex map explaining how all of these different pieces fit together. It makes it really simple, as you'll see in a minute, to come in next and figure out what happened. We've got a lot more visibility into what's happening within our application, and we can take that down to an individual user flow. When we get there, that's correlated with all the metadata that we've captured, plus the log files that went along with it. I just want to mention quickly, there's another option, which is auto instrumentation for ASP.NET. So here, rather than going in and changing my code, maybe I don't have access to the source code or I just don't have the time to do it, I can turn on auto instrumentation and it will plug into the web server pipeline. So for example, in IIS, this would plug in as an IIS module and give you, as you can see, most of the same feature capability without having to go in and touch our code. Obviously, you're not going to get business-specific things like the ability to filter by bunnies and kittens, because that's not something that the web server is aware of. But all of these libraries that plug in, we can auto-instrument them. And so if you've got maybe 100 projects that you want to add instrumentation to, this would greatly simplify it, doing it this way rather than going in and touching all the code. Okay, so I'm going to switch gears a little bit, and I want to talk about an error scenario. So in this case, in this demo, we're going to look at the same application, but I've ramped up the traffic 5x. We've suddenly seen this big spike in traffic, and we're starting to have a problem. And I know that there's a problem because I've been notified by a canary, which is part of synthetics. And so CloudWatch Synthetics is the ability to, this is another new thing that's happened fairly recently, is the ability to inject traffic, synthetic traffic in to make sure that we see what real user experience is like. And so I'm going to jump back into another demo here. And as we jump in, you can see I've set up two canaries here in synthetics. The first one is the site. So the pet site, this is sending HTTP traffic into our site, and you can see that it has failed. And then the second one there is the API canary. And so this is sending JSON requests into our RESTful services. And again, it has failed. But if you look at the success numbers, it hasn't completely failed, right? 94% of the time we're successful. So we're just starting to see the first few errors happen. And this is already notifying me saying, okay, something seems to be wrong. So I'm going to return to the service map, the same thing we were looking at. This should look very similar to what you saw earlier. But right away, you'll notice that a bunch of the Lambda functions over there in the bottom right have this little red line along the perimeter. And that's indicating the percentage error. If there were a higher percentage of errors, that bar would go further around and be a visual indicator that this is a problem. So both of those services are experiencing about 10% errors. So I'm going to dig back in, same way we did before. We're going to come back into the traces, and I'm going to filter them by the error code. So I'm only seeing those that have errored. And as we drill in, I can go into an individual user's experience, and I can see here that things were moving okay on the left side of this. But as we progressed through the Lambda functions to Dynamo, there were failures. And I see the same thing in the timeline. Things started out okay, but as we progress down through this waterfall diagram, we get down here, and we get down to DynamoDB, and there's a fault in Dynamo. If I scroll down again, I had done a good job of instrumenting my code, and so I'm seeing this exception captured here because I traced all the exceptions. And it says right away, the provisioned throughput for this table has been exceeded. So I am pushing DynamoDB faster than I have provisioned. Okay. Of course, if I scroll down, the logs are correlated just like they were before. And I can see at the end here that there's an issue in my Lambda function. And that has failed. And if I head up, I can see a little bit more detail about that, and I can expand this here. And if I do, it's really clear what's happening right away. I can see that this is coming from Lambda. So I'm seeing both in my trace and in my logs that both of this is being surfaced to me through these visual indicators that brought me to it really quickly. Okay, I want to go back to the service map for just a moment and call out one more thing. If we go back here, right, here's those same Lambda functions that we were looking at. And they ultimately call back into DynamoDB. And you can see that little warning message on there. That's telling you that there's an alert. We talked about alerts before, but we haven't seen them. So there is an alert related to the DynamoDB table. And if we click on one of these, it will take us deeper into the console, and we'll go over to the alerts page. And we can see that roughly 30 minutes ago, there was a big spike in traffic, and it brought us up above our provisioned capacity. And so we started running really hot here. Okay, and that set off this alarm. Great, so let's just review really quickly. So we saw how we can instrument our code, and we can use that to draw this nice picture and understand what the application looks like. When we had an error, we brought that same map back up, and we got these visual indicators, these red marks saying that we've got some, not everything's failing, but we've got a couple odd failures over here in this part. So we clicked on that, and then we used the filter capability to go in and look for an individual session that had failed. And once we got to that level, we could very quickly see what had happened. We understood that things were going well until we got down deep into this application. And when we clicked on those nodes, it very quickly surfaced the right error messages for us so we could immediately understand where the problem was. So we went from 10,000 foot and very quickly zoomed into exactly where the error was. I'm not going to dig into these links because we're quickly running out of time here. But there's a series of links that will be available after, and they will take you in so you can read more about how to instrument a .NET application and set up all of the things that I've shown you today. Quick call to action. So you need to configure this before you use it. So X-Ray, CloudWatch Logs, Synthetics, these are all things that you want to have set up long before you need them. You don't want to be trying to debug without these tools. So set them up ahead of time so that you've got the right tracing in place before something happens and you get woken up at 3 a.m. I'll call out a couple other sessions. These are all available already. And lastly, I just want to make a quick call out for feedback. It's really important to me that I get feedback on how this session went, what you liked about it, what you didn't like about it, so that I can make it better next time. So thanks, everyone. And please remember to fill out your surveys.